Hello, is my voice audible? Hello. Okay, let's start. Yeah. So, good evening, students. Welcome back to this lecture again, where we will be continuing with vectors. If you remember, in the last lecture, we actually uh, stopped at a question and then we said कि हाँ next time से भी वहाँ से ही चालू करेंगे. So we were left with some questions on addition of vectors. Let's complete that and then we'll move on to the next part. Welcome back again, everyone. Good evening to all. Come on, let's start today's session. Great. So here we'll be talking about this question. You can read the question and see for yourself. This is a classic question which is based on addition of vectors and regular hexagon. I hope you know the meaning of regular hexagon. First, it has given that ABCDEF is a regular hexagon. So let us draw a hexagon. It looks like benzene, or you can say cyclohexane. It looks like, correct. So this is A, B, C, D, E, and F. Right? Yeah. Okay. O is its center. So center of the hexagon, it is O. Then prove that. We have to prove that. If you remember this, prove that questions. So what we'll do is we'll see what we have on the LHS. Either we can use triangle law. Obviously, we'll use triangle law. So AB bar. So AB bar plus AC bar plus AD bar plus AE bar. So let me group some of these here. You will get to know why I grouped those. See, I'll write AB bar plus AE bar together. Since we need AD bar, so I'll keep this AD bar as it is. And next, we'll group AC bar plus AF bar. So, why I grouped this? Because you can see here, I will show it only for one. AE bar, since this is a regular hexagon, AE bar will be equals to BD bar. Both will be equal. AE bar will be equals to BD bar. So these both will be same. So that means instead of AE bar, I can write BD bar. And similarly, AC bar, you can see AC bar plus AF bar. So AC bar will be same as FD bar. And now our question gets over. So just need to figure out which ones to group and use the triangle law. So let's see here. Yeah, we are seeing AB bar plus AC bar. So I said AB bar plus AE bar can be written as BD bar plus AD bar plus AC bar plus AF bar can be written as CD bar. You can see here triangle law and here also triangle law. So I'll get AD bar plus AD bar plus AD bar, which is equals to 3 times AD bar. 3 times AD bar, hence proved. And here it is given that O is the midpoint. So if I join AD, this length will be equal to this length. So that means AD bar will be equals to 2 times AO bar, since O is midpoint. So this means 6 times AO bar. So we proved both of them. That is 3 times AD bar and is equals to 6 times AO bar. I'll again suggest you to practice questions on hexagon, because this is one of the special or one of the cases where we have seen how to use the hexagon. So according to the given, and using the properties of hexagon, we can easily solve these questions by using triangle law. I hope it is clear. Let's see the next question. Yeah. So in this, I think, yeah, we have options also. And we have diagram also. Yeah. So no need of diagram for us. We can obviously draw the diagram. But let's see the question here. ABCD is a parallelogram. You can see the parallelogram. And AC bar plus, sorry, AC square. Now mind it, this is not a vector. AC square is not a vector because there is no bar obviously. So AC square is length of side or diagonal AC and this is length of diagonal BD. So I'm showing you for AC, if I take the triangle like this, you can see the triangle A, B and C. So from that, I can write AC bar is equals to AB bar plus BC bar. We are basically using the reverse of triangle law. Most of the times we are given this AB bar plus BC bar and we write this. This time we are using reverse. That means I am given AC bar, I am using this. So what is AC bar? We don't want AC bar, we want length AC. Length AC means mod AC bar equals to mod of AB bar plus BC bar. And we want it square. So let's square it. And similarly, we can see that BD bar can be written as BC bar plus CD bar. Now, since it's a parallelogram, what is the property of parallelogram? That opposite sides are equal. Equal means equal in length and parallel. That means I can write CD bar as BA bar. So BC bar plus BA bar. And if you remember yesterday's lecture, I can write BA bar as minus AB bar. And here BD bar, we want its magnitude, so magnitude we want it square. Now, this is AC bar, this is BD bar. We want to add those. So if I add these, I'll get AC square plus BD square. Mind the notations, AC square means same as mod AC bar ka square. And BD square means same as mod BD bar ka square. Correct. So here, if you use this, you know A plus B ka formula. We have not done this formula in vectors yet, but I hope you know. So just assume कि formula आता है अपने को, even if you know or don't know, because we are anyways going to cover in the next session in dot product. So A plus B the whole square is A square plus B square plus 2AB. But here we have AB bar dot BC bar. Since we are in vector, the formula is same. A square plus B square plus 2AB. Here just we have A bar dot B bar. And add this. So plus BC square plus AB square minus 2AB dot BC. This gets cancelled. And you can see AB square plus AB square 2 times AB square. And BC square plus BC square. I hope you can see this, or should I? Okay. AB square, BC square, BC square. So AB square plus BC square. This is my answer. So option it is this one, 3. So 2 times AB square plus BC square. I hope it is clear. If it is clear, give me a thumbs up so I can move on to the next question. Come on, guys. If it is clear, please give me a thumbs up. I'm waiting for that so we can move. If you can see, you can again revise the question or you can look at the question again. Super. Chalo. Let's see the next one. Again, it's a question on hexagon. I think we already did this question, right? Just the naming has changed. Last to last question यही किया था. Just the center was O. So here it becomes lambda AO bar. Do you remember what was it? AB, AC, AD, AE, AF was equal to 3 AD bar, which is equal to 6 AO bar. Why? Because O is the center of the hexagon. So that means what is the value of lambda? It is 6. So we already did this question. So we'll not do it again. I hope you remember it. Chalo, let's see the next question. Yeah. Now, today, let me tell you, we are completed with addition of vectors. Now we are moving to 3D coordinate geometry because 3D coordinate geometry is essential to study vectors. So we'll just look at the 3D coordinate geometry and jump right back into vectors. So what next topic says is कि if I want a vector to be represented in coordinate plane, such as in 2D plane we have the xy plane. So if I have the xy plane and I want to represent the vector here, as we already know, we represent a point 2, 3, and the position vector associated with this point is a bar. So how can I write a bar in terms of 2, 3? So that we are going to learn today and apply in the question. So that is what this is the basic. You must have studied this in physics already, but let me again revise this. So it is said in the rectangular Cartesian system, I, J and K. I, J and K are basically unit vectors which are along positive x, positive y and positive z axis. And along the positive, as you can see, next what it says that let A bar, B bar, C bar be vectors. So these are three non-coplanar vectors. And if there is a vector R bar which is written like this, which is x A bar plus y B bar plus z C bar, then x, y, z are called components of R bar. And the vectors A bar, B bar, C bar are called base vectors. So this is a general definition of vectors. That means if I write R bar as 3 in terms of 3 vectors, so A bar, B bar, C bar are called base vectors, and x, y, z are called component. So in Cartesian coordinate system, my I cap, J cap and K cap will be base vectors. It should be cap actually because these are unit vectors. So in Cartesian coordinate system, the base vectors are I cap, J cap, K cap, which are along positive x, positive y, positive z axis respectively. So that means in the Cartesian plane, I can easily write any vector. Why? Because I know the base vectors. So if I know the base vector A bar, B bar, C bar, I can write R bar. Similarly, here Cartesian plane, we know the base vectors I cap, J cap and K cap. That means any vector on the Cartesian plane, I can write it in terms of numbers. So let's see here. Oh, I think I made some error in the slide show because the topic is coming last. It's okay. Uh, 1 second. What happened here? Yeah, we saw all this. Yeah. Again, I think there is some issue. Okay. So here that is what I was talking about. Base vectors are I cap, J cap, K cap. And if I have a point Px, y, z, then the space vector is denoted by xi cap, yj cap, z k cap, where x, y, z are the coordinates of the point and I, j, k are base vector. That means I can write a coordinate of the point in terms of a vector. So let us say I have a point 2, 3, 4. I have a point 2, 3, 4. Yeah. So what can I write A bar as? Very simple. I can write A bar in terms of I, J, K. Why? Because those are base vectors. The point is X, Y, Z. So vector will be this. So that means 2I cap plus 3J cap plus 4K cap. That means any point, we already knew that I can write any point in terms of vector. But how to write that? We studied now. After studying I cap, J cap and K cap. So what I'm going to say, let's see the next slide and we'll understand it more. So we all know or we have studied the space vector. So every vector can be represented as a space vector. As a space vector means in 3D space. In 3D space means in terms of I cap, J cap and K cap. That means in coordinate plane. Chalo. Achha, if a vector is 0, then all the components are 0. We discussed this already. That means if r bar is 0, then x, y, z are all 0. So if two vectors, then this is basically addition, simple addition. If two vectors are given in terms of a bar, b bar, c bar, and I want to add that. Very simple. Add the coefficient of a bar, add the coefficient of b bar, add the coefficient of c bar. So it is same as normal addition. Let's see the next one. Length of a vector. Yeah, very important. We all know that if the vector is a bar, then its length or magnitude is denoted by mod a bar. So let's say if the vector is xi cap plus yj cap plus zk cap, that means in terms of base vectors. So what will be its modulus? Then its modulus will be under root of x square plus y square plus z square. You can see here x is the coefficient of I, y is the coefficient of j, z is the coefficient of k. तो अंडर रूट का उसका स्क्वायर कर देने का. Got it? Now, yeah. Vector joining 2 points. This we already studied. We know that if 2 points are A and B and there is a vector joining them from A to B, I can represent it by AB bar. But now we know that I can represent A bar in terms of IJK. I can represent point B in terms of IJK. So that means that I can represent a vector AB bar in terms of I, J and K. We already know I can write AB bar as B bar minus A bar. Correct? So if here they have taken P and Q. So if this is P, this is Q, then PQ bar will be Q bar minus P bar. Let me write it here. PQ bar will be equal to Q bar minus P bar. What is Q bar? This. So x2, I'm not writing ijk, comma y2, comma z2. This is respectively this I, j and k minus. What is p bar? It is this. That means x1, y1, z1. So if I subtract those, I will subtract with I. So x2 minus x1, j will subtract with j and k will subtract with k. So I got pq bar as this. And what is modulus of PQ bar? It is under root of I का कोएफिशिएंट का स्क्वायर प्लस J का कोएफिशिएंट का स्क्वायर प्लस K का कोएफिशिएंट का स्क्वायर. So it is very simple. Let's move on to the next part. This is theory part. Yeah, we are now in the MCQs. Chalo. As you know our pattern, we already see which MCQ, we already start the MCQs with the topic just completed before that. So what is the option? Come on, guys. What is the option? Yeah. What is the option? Very simple. 3. Superb. Option 3. Chalo, next. Yeah. This is a nice question. This is the application of all the things we have studied till now. यूनिट वेक्टर आ गया, उसमें पैरेलल आ गया, IJK भी आ गया. चलो, I let you try this. If not, then we'll study. We'll do it right now. So yes, please. All the three concepts are there. What is meant by parallel? What is meant by unit vector? No one? Okay. Let me... One second. No one? Okay. Let's see. So here it is given parallel. Now, two vectors are parallel. What is the definition? That means they lie along the same line. This line. Correct? One vector can be magnitude something, one vector can be magnitude something. Let's say I write this vector as A bar, and this is A bar, and this is some another vector. Suppose let's say A cap. Why A cap? Because it is a unit vector. It is a unit vector. That means whatever the length of this is, its length I know. The length is 1. Correct. So we all know if two vectors are parallel, then I can write A bar equals to K times A cap. Correct. Now here in this case we know K. Why? Because A का magnitude तो 1 है. A का magnitude कितना है? 1. If I want A bar, then I need to multiply A cap with its magnitude. So A bar equals to mod A into A cap. I hope you got it. Or you can read it like this also, ki vector equals to magnitude into direction. Vector, we have studied this, is equals to magnitude into direction. And yesterday's class, I was very stressful that direction is usually given by unit vector. And you can see magnitude is mod A, direction is A cap. So from here, I need A cap. So I can write A cap is equals to A bar upon mod A. We already know this formula, right? What is A bar? It is I cap minus 3J cap minus 5K cap upon modulus of A cap under root of coefficients ka square. So that means I got I cap minus 3J cap minus 5K cap upon 25 plus 10. So under root of 35. Now I'll put plus minus here. Why? Because direction is not mentioned. They have said parallel. In parallel, we know there are two cases. 4 ho gaya, two cases that is like and unlike. This and this. That means they both could be like this or it should be like this. And we know that if vector direction changes, then just it is a difference of plus or minus. So here, which is the option? I guess it is fourth one. Correct? Clear till here? Is this question clear? Give me a thumbs up. Then we'll move on to the next question. Is this question clear, guys? We'll move on to the next question. Yes or no? Yes, very good. Chalo. I think we have our next question. Yes. Do we have option? It again got stuck. Okay. We'll... Yeah. Here are the options. Same question as previous. See. Same you can see, unit vector parallel to a vector, but in the opposite direction. That means this time they also give the direction. Last time direction was not fixed. Therefore, we had to put plus and minus. Here the direction is fixed. Opposite direction means -1. So, same question. Let's say you keep this vector as m bar. So, we'll start with same. M bar is equals to mod m into m cap. So I'll get m cap is equals to m bar upon mod m. Let's get m bar. M bar is a bar plus b bar plus c bar. So my m bar will be equals to a bar. This plus this plus this. Obviously, this is basically I cap, j cap, k cap. Same here, same here. So we'll add the I1 first. 215, which is 8. Let's add j cap 1 minus 1 minus 1, which is -1. Let's add k cap -1 0 1. So plus 0 k cap. So what is m bar? I think we made some mistake. A bar plus b bar minus c bar it is. So 2 plus 1, 3. 3 minus 5 minus 2 I cap. Yeah. 1 minus 1 0 minus 1 plus j cap. -1 -1 minus 2 k cap. Yes. Now it's fine. So this is basically minus 2 I cap plus j cap minus 2 k cap upon under root of coefficients को square करके add. So 2 square plus 1 square plus 2 square. So this gives us 4. 4 8 plus 1 9. So 3 आएगा नीचे. So minus 2 I cap plus j cap minus 2 k cap upon 3. But what is the direction? Negative sign. So I'll put a negative sign here, which will reduce the vector to 2 I cap minus j cap plus 2 k cap upon 3. This is my answer. Simple. Is there option matching? No. Yeah, it is option 1. This was the same question as previous one, just a bit like modified. Here you can see. Is it clear? Let's move on to the next question then. Again, this is, let me check. You already solved this, right? Yeah. Let's see the next one. Come on. This is a very simple question. What does it say is OA bar, AB bar, AC bar is given. Find the position vector of D bar. Let me just tell you, position vector of D bar means OD bar. I want OD bar and I am given OA, AB, BC, CD. Very simple use of which law, guys? Which law? I think it is triangle law. So simply I can write OD bar as OA bar plus AB bar plus BC bar plus CD bar. See, triangle law, A, B और C. तो directly OD bar मिल जाए. Correct? So this is very simple. Just add these vectors, but the clicking part is important. कि हाँ, I can get it like this. So सबको add करो OA, AB, BC, CD. Just tell me the coordinates in the chat box. What will be coordinates or coordinate form? These are not coordinates. Actually, in this case, they are coordinates because it is position vector. Come on. Add them, add all the vectors and tell me the coordinates. Ha. What are the coordinates? Ha. You can see the question now. Come on, guys. This much time in adding. नो, अरे बाय ऐड करने के खाली इसको ओ ए बी बी सी और सी डी, आई को आई के साथ करो एंड सो ऑन. देवन, स्वाति, व्हाट अबाउट यू ऑल? तो ये लास्ट वाला नहीं दिख रहा था क्या? नाउ इट्स गुड. वेकेशन मूड में है क्या सब लोग? दिवाली वेकेशन. Okay. So it will be 1, 3, 4, 5, 6, 7. 7 I cap. J 1 minus 2 minus 1 plus 2 1 plus 1. 2 J cap. And K के लिए 1 plus 1 2 minus 2 0 plus 3. So 7 I cap plus 2 J cap plus 3 K cap. Let's move on to the next question, guys. If the position vectors of A, B, C are given and we have been given this, find lambda. So this is a classic question, very simple one. Why? Because we know that AB bar is B bar minus A bar. So this is basically position vector. This is A bar, this is B bar, and this is C bar. So AB bar equals to B bar minus A bar. Just subtract those. So I'll get minus 2I cap. I am subtracting this minus this. So sign will get changed, plus J cap plus 3K cap. And similarly AC bar. AC bar will be C bar minus A bar. Subtract C bar and A bar. So 8I cap minus 4J cap. Correct? Minus 12K cap. So as you can see in AC bar, I can take minus 4 common. Why I took minus 4 common? Because you will see, if I take minus 4 common, I'll get minus 2 I cap plus J cap plus 3K cap, and to your surprise, what is this? A B bar. This is A B bar. So that means I can write AB bar is equal to minus 1 by 4 AC bar. So this is the value of lambda. It is minus 1 upon 4. Simple. Okay. Let's see the next question. Did you all understood it? If it's clear, give me a thumbs up. Come on. If it's clear, 100% clear, give me a thumbs up. Yes, I'm waiting for you guys. No one? Are you all there in the meeting or just? Okay, super. Devan is there. He only knows to give thumbs up. But calculate bhi karo bhai aaj. Today I'm getting actually bored because you are not communicating. Busy with something else or exam and all, practical, I guess. You can clear it out at the start of the class only. So I can teach accordingly. Now I'm waiting for your replies. It's fine. Chalo. Let's see the next one. Yeah. This is the third time we are doing the same question. Why? Because find the unit vector in the direction. Now, if the direction was not given, we would have taken plus minus. But in the direction means we have to take plus. Uske direction mein na. So that's why we have to take plus. Yeah. So let's see. Let m bar be equals to a bar plus b bar. So what m bar will be equals to 4 I cap plus 3j cap plus 3k cap. We know that m bar is equals to mod m into m cap. We want m cap. So m cap is equals to m bar upon mod m. What is m bar? M bar is 4 I cap plus 3j cap plus 3k cap upon under root of 4 square plus 3 square plus 3 square. So we have to take plus sign, right? No need to minus because it is given in the direction of. So this will be 4 I cap plus 3j cap plus 3k cap upon 9 plus 9, 18, and 18 plus 16. It is 34. This is my answer with a positive sign. Come on, let's see the next one. Yeah. Now, this is a good question because it is given there is a triangle. There is a triangle where any direction, I don't know the directions. So let's say this vector is a bar, this vector is b bar, and this vector is c bar. So let's say this is a bar, this is b bar, this is c bar, and they are saying this triangle is a equilateral triangle. So what we have to do is equilateral triangle को prove करने के लिए what we prove, all the sides are equal. So here the sides are a bar, b bar, and c bar. So what will be the length? Length will be mod a bar, mod b bar, mod c bar. चलो, what is mod a bar? ये रहा इसका modulus, which is under root of 3 square plus 5 square plus 2 square. I'll come this side. What is mod of b bar? It is 2 square plus 3 square plus 5 square. And mod of c bar, 5 square plus 2 square plus 3 square. As you can see, the same numbers are getting square and add. So 9 plus 25, 34 plus 4, root 38. ये भी वही है ना, 5 square 2 square 3 square, root 38. ये भी वही है 5 2 3, तो root 38. All of the length of the sides are equal, and equal means the triangle is equilateral. Got it? Chalo. Let's see the next one, which is the next topic. Yeah, we'll be starting with next topic. You can see those are linearly dependent independent vectors. Now, let me tell you something about this topic. This topic mainly comes in your 4 marks questions in NCERT, that means in your boards. These are very famous questions about linearly dependent independent vectors. First, let us understand the meaning of what is meant by linear dependent and linear independent. Dependent means dependent on something, independent means independent of something. Correct? So, yeah, let's see. So before that, we need to learn linear combination. Again, it happened. Okay. So before this, we need to learn linear combination. What is linear combination? This is linear combination of vectors, right? I hope you have studied linear combination in matrices, I think. Correct? Linear combination means there will be many vectors and we can adjust them so that when we add them, their sum becomes 0. Their sum becomes 0. So linear combination means addition of vectors. Now, how do we add them? By using constants. So let's say these are n vectors and L1 से लेके Ln तक. These be n scalars. So this quantity L1 A1 bar, L2 A2 bar, Ln An bar is called linear combination of these vectors. Now, linearly dependent vector means the linear combination of these vectors is 0. That if the vectors a1 bar, a2 bar, an bar are linearly dependent, then their linear combination will be equal to 0. If the linear combination is equal to 0, that means the vectors are linearly dependent. Correct. So independent का मतलब क्या होगा? You already predicted कि linear combination will not be equal to 0. अगर 0 नहीं है, that means the vectors are linearly independent. अच्छा ये तो yeah, linearly independent if linear combination is not equals to 0. Now obviously बात है collinear vectors are linearly dependent. Why? Because I can write a bar equals to kb bar. If there are two vectors a bar and b bar which are collinear, and I can write this as a bar minus kb bar equals to 0 bar. What this means? This is linear combination of a bar and b bar where L1 is equals to 1, L2 is equals to minus k. L1 a bar plus L2 b bar. So this is a linear combination. It is equal to 0. That means collinear vectors are always linearly dependent. Next is coplanar vector. We'll study this, but just remember it is a standard result. Coplanar vectors are linearly dependent. So the reverse is also true. That means that three vectors are coplanar if linearly dependent. कोप्लेनर वेक्टर लीनियर डिपेंडेंट है और अगर कोई तीन वेक्टर लीनियरली डिपेंडेंट है देन दे आर कोप्लेनर. सिंपल. कोप्लेनर वेक्टर्स आर लीनियर डिपेंडेंट मींस द वेक्टर्स आर कोप्लेनर. Let's see the next. Let me fix this again. I don't know why is it happening. Yeah. So obviously we can see the same thing here. If linearly dependent vectors are coplanar, then linearly independent vectors will be non-coplanar. Excuse me. And you can see any four vectors are always linearly dependent. That means if I am given any four vectors, then all of them will always be linearly dependent. So here I have something. Yeah. See this. Aram se. We will be studying this in coplanarity, but I'll introduce it here. So there are three vectors, A bar, B bar, and C bar. And if these three vectors are linearly dependent, that means the determinant of their coefficients a1, a2, a3, a1, a2, a3, b1, b2, b3 second row, c1, c2, c3 third row. The coefficients of their ijk का determinant will be equals to 0. This is a very important condition. So if in any case I am given that three vectors are linearly dependent, or I can be given three vectors are coplanar. One second. Coplanar. Because we saw that linearly dependent is as good as coplanar. So if three vectors are linearly dependent or coplanar, that means determinant of their coefficients will be equal to 0 and also vice versa. Clear है? चलो. Same thing, coplanar is given. Why coplanar? Because in last it was given linearly dependent. We discussed it there only. And are linearly independent. When they will be linearly independent? when the determinant is not equals to 0. So here you can see the same thing. Determinant is not equals to 0. So let's look at the options. We studied this just now, 2-3 minutes back. Let me show the question to you. Please say the answer. Come on, guys. Three collinear vectors are linearly dependent. We just saw, right? Scalar multiple, and that means the same thing. Correct? Chalo. Uh, yeah. What is the answer to this, guys? We saw this, right? Yeah. Coplanar if the determinant is 0. Correct. Let's see the next one. We saw this. This is a linear combination. And if linear combination of some vectors is 0, that means those are linearly dependent. These are the just standard results we just saw. Right now? Chalo. Let's see what about this. Come on. I hope you guys gave the answer to this. Come on, guys. Let me check if you understood the analogy between collinear, linearly dependent, coplanar, and all. Come on. Coplanar is given. We just now discussed there is the vice versa case in all. First one, superb. So coplanar means linearly dependent. Very nice. Let's see the question here. Chalo. Vectors are linearly dependent, or you can say though they are coplanar. Just now we saw the condition. If the vectors are coplanar or linearly dependent, so that means the determinant is equals to 0. Now whose determinant? The coefficients ka determinant. Here actually they should be bar, right? These are vectors a bar, b bar, c bar. What are the coefficients? 2, minus 1, 1, 1, 2, minus 3, 3, m, 5. So this will be equal to 0. So let's solve this. So I'll get 2 into 10 plus 3m plus. I hope you know how to expand a determinant. 1 into 5 plus 9 plus 1 into m minus 6 equals to 0. So this will be 20 plus 6m plus 9 plus 5, 14 plus m minus 6 equals to 0. So let's add m, 6m plus m, 7m. 14 minus 6, 8, 28. That side जाके minus 28. So m is equals to minus 4. Simple as that. Got it? Let's see on the next question. Yeah. The same question is there. Come on, guys. I need you all to calculate. The vectors will be उल्टा पूछा है ना. लास्ट सम में दिया था कि they are coplanar. That means determinant will be equal to 0. Here they are asking whether they are coplanar, collinear or not. So that means we have to find the value of determinant. So first vector is this, second, third. This is 1, 1, 0, 0, 1, 1, 1, 0, 1. Check this value. If it's 0, actually linearly dependent and coplanar, these both are same options, right? Almost same. What is the value? I guess it is 1 into 1 minus 1 into 1 minus 1 into 0 minus 1 plus 0 is equals to 2, which is not equals to 0. And that means those are linearly independent. Why linearly independent? Because the discriminant is 0. Now, I guess we are correct about this option, but actually the more correct option is this. Why? Why? Because you can see if those are sides of equilateral triangle, A bar, B bar, C bar. See what is mod A? Mod A is root 2. Mod B is also root 2 and mod C is also root 2. That means all of the vectors are sides of an equilateral triangle. Obviously, they are linearly independent. But the more correct answer, since we don't have multiple choice in JEE mains, the more correct answer would be side of an equilateral triangle because it is satisfying both the conditions. C. So the option is D. So today's session was like okay because you didn't connect with me, talked with me, but it's fine. I guess you were busy or traveling or anything. Let's make sure this does not happen on the next session. Anyways, after this, we'll be doing some 2-3 questions are left and time is up, so we'll end the session. But after this linearly dependency, we will be using or we will be doing section formula. So today is Friday. We'll be seeing you or we'll be seeing each other on Monday. So I hope to see you all guys on Monday. We'll be studying section formula. Till then, bye bye, take care. Thank you all.